Whether blue, green or brown, almond, hooded, close set or wide set, we all have two eyes that grant us the amazing gift of sight. However, the differences between your eyes and mine lies not only in the colour and shape, but much deeper under the surface. Just like our fingerprint, we each have a very unique number of photoreceptors inside our eyes, making the way we view the world something that is very personal and unique. Earlier this year, this incredible phenomenon was experienced by millions, as a single image of a dress divided the online world. Baffled by whether the dress was blue and black or white and gold, the online world was sent into overdrive as a single image became an overnight sensation. 58% of Facebook users saw white and gold, yet 42% saw black and blue. Suddenly, everyone wanted to know exactly why different people were claiming to see different colours.
Yes, it is dividing people into two very distinct camps, white and gold versus blue and black, and the issue is taking on really a life of its own. Garnering more than 21 million views.
How's that white? It's blue.
It's white. It's tearing apart friendships and families.
Seeing white and gold, where are you looking at?
So how does the human eye work? Inside the eye lies an intricate and complex workshop whose primary role is to detect, receive and control incoming light. Referred to as the window of the eye, light rays enter the eye through the cornea. The cornea bends the light so that it can pass through and enter the pupil. The pupil lies in the center of the iris. The iris shrinks and enlarges depending on the intensity of light that is entering the eye. After passing through the iris, the rays of light pass through a clear, flexible structure known as the lens. The lens helps us to focus the light onto the retina located at the back of the eye. The retina is a light-sensitive layer. The retina receives the image that the cornea originally processed, and it transforms this image into an electric pulse that is carried by the optic nerve to the brain. It is lined with millions of photoreceptors known as rods and cones. Rods are light-sensitive, telling us if there is any light in a certain spot or not. Cones are colour-sensitive and tell us what colour the light is. Rods are used for seeing low light conditions. However, there are three types of cones that correspond to the colours blue, red and green. When you see a colour, each cone sends a signal to your brain and activates to form the colour you are seeing. Since that day back in February, we now know that the image of the dress is an optical illusion. Optical illusions occur when our two eyes and brain don't agree, causing confusion about what is being sent to the brain. Optical illusions often possess visual characteristics that are difficult to focus on. Unable to process all the information at once, your brain simplifies the image by choosing a focal point. When the brain processes an image, it subtracts the image itself from the lighting and background colours surrounding it. Although they may appear to be different, these two circles are actually the same colour. They only appear to be different because your eyes cannot decide which background colour is which. As a result of the highly saturated light on the right-hand side of the dress, and the poorly saturated colours of the dress itself, for those who see the dress as white and gold, your eyes may be subtracting the wrong background colours and lighting. The dress proves that the context in which we see images is crucial to the way our brain will perceive them, and most importantly, that seeing is certainly not always believing.